Hello everyone, let's take a look at our next problem. A container in the shape of a right circular cone is 12 inches tall and has a base, and its base has a 5-inch radius. The liquid that is sealed inside is 9 inches deep when the cone is held with its point down and its base horizontal. When the liquid is held with its point up and its base horizontal, the height of the liquid is m minus n times the cube root of p, where m, n, and p are positive integers, and p is not divisible by the cube of any prime number. Find m plus n plus p. Okay, so this is just going to be a test of geometry and volumes and understanding how the volume of a cone works, or even, the relative volume of a cone or part of a cone. So the idea here is I have, a regular circular cone, a right circular cone, like an ice cream cone. It tells us the dimensions, 12 inches tall, and its base has a 5-inch radius. When I'm holding it like an ice cream cone, the liquid inside is 9 inches deep. When I turn it around, with the base at the bottom now, the height will be less than 9 inches, and we need to figure out what that height is. So we're going to start with a diagram for sure. I'll draw the diagram with the point down, because that's the initial sort of state we're given of the cone. So the height of the cone is 12. The radius of the cone is 5. And in this orientation, the liquid has a depth of 9. So I think the best way to do this is to just solve for the volume of the liquid. We can do that because the radius here, sort of the radius where the top of the liquid is, will scale in proportion to these two numbers from 5. So, 9 is equal to 3/4 of 12. So this radius is going to be 3/4 of 5. And so the volume of the liquid is going to be the volume of the cone formed by the liquid, so the like the yellow part, which is what is the volume of a cone? It's 1/3 times h times r squared. Yeah, where h is 9 here, and r is equal to whatever that number is, I guess 15/4. And then what I will do is I will draw another picture where the cone is flipped upside down. And we're going to have to solve, we're given the volume. The volume of the liquid is, of course, not going to change. That'll be the same. And we'll have to solve for the new height of the liquid. I'm missing a factor of pi here, aren't I? Right, the volume of a cylinder is the area of the base times the height, so it's pi r squared h. To get the cone, divided by 3, right? So the way I'm going to do this is basically I'm going to compute the volume of the entire cone, and I have the volume of the liquid, which is the same whether the cone is facing up or down, and I'm going to express the volume of the empty space is, of course, the volume of the entire cone minus the volume of the liquid. And I'm going to write that in terms of this parameter h prime. And then I should be able to solve for h prime by, setting the volume of the liquid part or the empty part to be the known quantity that we have from above. Okay, so working through all of the geometry and equations and just solving for everything, this is what I end up getting. I don't, fairly confident in the answer here. It's possible I made some arithmetic mistake. I don't think I made any errors with the substitutions of things, right? Like the geometry here, I'm confident in. The geometry here, I'm confident in. Setting volumes equal to each other based on whether the cone is flipped right side up or upside down is fairly straightforward. But maybe there's a cleaner way of going through all of these equations. I was keeping track of dimensions of variables as I went through, so I think things, I never had a contradiction in the dimensions of things. This is a distance cubed, this is a distance cubed, that's a distance cubed, and this is unitless. So that kind of thing never ended up being a problem. And then just working things out, simplifying this expression as much as possible to get things into lowest terms. I end up with the thing under the cube root is a 37, which is not divisible by any cube number. So in fact, the correct answer here, this is the expression m minus n times the cube root of p. So m plus n plus p in the end is 12 plus 3 plus 37, which is 12 plus 40, which is 52. And I'm pretty confident that's the correct answer. So if I find any errors or if I have any additional comments, I'll put them in the description. Otherwise, thanks for watching.